So we resume from here, score string, and then when you run it, it takes in a value. The important thing I want to point out is anytime you use this input value and you type in the value or your name, it always comes in as a string. So many times as engineers, we want to do calculations with numbers. So you type in 90 and you think you can multiply 90 by something or do some calculation with it. Like say you want to do score string times 2. You want to multiply whatever the user provides by 2. And then you'll be surprised at the answer you get, right? Because this is what you will. Let's see what you get. Let's do something small. 2. Enter. And then it shows 22. You're wondering, 2 times 2 is not 22. Well, we'll see the reason why it's 22 shortly. But the important thing is that this is a string. So there is no multiplication operation on strings. It does something different. It actually prints out the string 2 times. That's why it shows 22. So if you do times 4, then it's going to print 2 4 times, because what you read is a string. The input function will always take in your value as a string. So what do you need to do? Before you do calculations, you need to do the data type conversion we talked about, right? So we need to convert it. So I can create a new variable and call it score float. It could be integer if you know you're going to be asking for integers only. And then you will use the conversion, right, that we talked about just earlier here, right? For conversion between data types. So here you're converting from string to floating point precision. And then you provide what you read in, which is stored here. Good programming practice. Just copy these things because it's case sensitive. If you come in here and you type score string with small letter, let's do it. If you do this, the code does not work because there is no score string. It's not a variable. And you know it's a computer, right? It doesn't second guess what you're trying to achieve. It doesn't. Computer will complain. Score string is not defined. But I defined it. No, you define score with capital string. So Python is case sensitive. And we talked about that in topic 1. So always a good idea to just copy variables and paste them. That way there is no room for error whatsoever. When you run it, it works as intended now. Because you took in a string, you typed in the value thinking it was an integer or double point. We typed in 2, but it came in as a string, and then we parsed it into the float function, and the float function will convert it from a string into a float, and then we do calculation. So we need to do calculation with the score float, right? And like I said, to avoid mistakes, always a good idea to Control C, to copy this guy and paste instead of typing it and making mistakes. But anytime you see those errors I showed you, which is like variable undefined, first thing to check is, did you accidentally use in the wrong variable name? And then the new variable name, which is a typo, does not exist. So now it will do the correct calculation, right? Because we have taken in 2, we typed in 2 as a string, converted it from string to floating point 2.0. So score float now holds a value of 2.0. And then it multiplies 2.0 by 4 and gets you 8.0. And you can do all of this on one line, like so. Because, like I said earlier, Python is a concise language. So all of this, which is stored in score string, right? That's what is stored in score string. You can copy it and then put it in place of score string. That's what score string represents, right? So you can nest those 2 function calls. So it first does the input. When the result of what you typed in is available, meaning when you hit enter after typing a variable, Then it converts whatever you type in into float, and this will be float, and this works the same way. So you can do everything in one line or do it in two steps like I showed earlier. And then if you do score string plus score string, strings they don't do addition when you use plus. It will just concatenate them, meaning it will put the first one next to the second one. So it puts 2 next to another 2, and it prints 2, 2, which is not 22 because it's a string. So very important, when you bring in value, convert it to the data type you need it in. So if you want it as an integer, you use int around this function. If you want it as a floating point number, you use float around the input. Very important. You will need this. And then if you forget, your code will not do the right, it will not perform the right calculations. And now we move on to packages, Python packages, meaning code that someone else wrote but could be useful for you. So there is a math package that is available external to Python, external to the core Python functionality, but it allows you to perform lots of mathematical operations like cosine, hyperbolic, tangent, all sorts of trigonometric operations and more. So how do you import packages that are available in Python? You use import function. So you can simply say, let's do it from scratch. You can simply say import. So import the math package. You can import math. And then if you want to find Q, flow rate, from the equation I'd given before, I'm going to type it. No, I wouldn't do that. That way I'm not teaching you wrong programming practice. So initial flow rate is 5,000. I'm just coming up with some decline curve parameters, right? We talked about decline curve analysis or exponential decline curve model just earlier. So this is my initial decline rate, and those are the only 2 parameters I need in the exponential decline model, and I can calculate my Q as Qy, which is initial flow rate, times, right? Remember, you don't do this and expect MATLAB to do multiplication. If you want to do multiplication, well, tell Python to do multiplication by using the multiplication operator, which is the star. So Qy star exponential, right? But exponential is defined in the math package. So you will have to do math, which is this math you imported, right? Dot exponents. And you can see all sorts of functions available in it by doing tab. Yes, and it shows you exponent. If I back up right after typing in the dot, you can do tab and you will see all sorts of functions available. So I put the dot and then I press tab on my keyboard, and then you see all the functions available within the math package right here. So exponent is what we need. So what's the equation? It's minus di, and di is provided here, times time. You're not going to put dit, right, or di into parentheses t. Use the multiplication operator, and we are done. So we don't have time here, right? So generally you will provide the time. So time could be after 10 days. What will the flow rate be? It's a simple control enter, and I didn't ask to print anything, so I did the calculation and moved on. So let's print, and we want to always use printf, right? So you see how I'm building up my functions. Always a good idea to do it that way. Open and close parentheses, and open and close curly stuff, then do the F for formatted, and I can say flow rate Q equals, then I use this curly brackets and print out Q. If I want to show the units, I can say stock tank barrels per day afterwards. And you can run this and it tells you flow rate Q equals this STB per day. So we have used the math package. What if the package is so long say the package was mathematics, and then you will have to type mathematics.exp, right? So instead of doing that, you can import and then give an alias for the math and make the alias sound reasonable. So that's what we did here, right? In the first cell above. So you can import any package name as, then you provide the shortened alias you want to use. So I choose to use empty. And then from now on, you can use empty here instead of math. So because you imported math as empty, you can do empty.exponent and it will work as is. What you don't want to do is to import as empty, then come in here and type math here. Or import as empty, or better still, import as math and then you try empty. It has to agree. You can either do this and type out math in full, or import as empty and do empty as we have here. Good. You can also import NumPy. We talked about NumPy for numeric Python. You can import it directly, and that means to use it, you must type NumPy dot whatever function. Or you can import NumPy as NP, and then you can do some calculations using NP dot exponent, for instance. NumPy also has its own exponential model, like you can see here. Again, just use dots, and then you can see tab. You can see all the functionalities available from that package. You see, it's a lot. And we'll be using NumPy for arrays, calculations involving arrays. Say you want to calculate flow rate for 10 rows of data, then you will have to use the NumPy's exponent model and not math. This math will only calculate for one value, so scalar values. If you want to do array calculations, you have to use the exponent model available here. Very important. We'll get there in the workbook session, but when you start to work on your lab workbook. So if you want to work on multiple values, a collection, meaning an array, a list, you want to use NumPy, because NumPy is what was developed for mathematical calculations on arrays, matrices, and things like that. Math will give you exponents for one value, so you don't want to put an array here. You can say this is just one value, but here you could put in t, where t is an array of different times, like 0, 10, 100, an array, and this function will give you an array as the output, an array of flow rates, and we'll get there later. Absolute value, this is standard functionality in Python because we're not using math.apps or numpy.apps. This is in standard Python, and it will give you 3.3 as the absolute value of minus 3.3. We already talked about importing math package. You can use sine from math package. You can use square root from math package. You can see it's working on one value at a time, scalar values, not an array. We want to do arrays, you use NumPy for them. Square root, exponents. You can do log. Log does natural logarithm and not log to base 10. To do log to base 10, you use log 10, still from the math package. If you imported math package as empty, like I did here, then all of this math should be empty, right? All of this math type here should be empty. And this is a good point to stop before we move on to strings.